All right, so we're going to start section 6.1 part 3, and we are still graphing today. So may want to get your graph paper out. Now I'm starting the PowerPoint with a little bit of review from what we learned in the first couple parts of this section. So all the stuff that I'm going to put up here first is stuff that should already be in your notes. When you've got the integration with respect to x, as far as finding the area goes, to do that, you have to set up an integral from a to b, a being the x value on the left, I call that the lower bound, b is the x value on the right, I usually call that the upper bound. And to get the integrand set up the right way, these have to be in a very specific order. Once you graph your functions and you find the bounded region, you always have to take the function that forms the top part of the region minus the function that forms the bottom part. So you kind of have to figure out what f of x is and what g of x is on your own. So it was always top minus bottom. Now, with the problems that we do today, we are going to be integrating with respect to y. So I'll set up another integral down here, but there are some significant differences between integrating with respect to x and integrating with respect to y. Notice I put C and D instead of A and B. That's not real important. You could leave it as A and B if you wanted, but they are going to be in different spots. It's not going to be left x value, right x value anymore. If we're integrating with respect to y, think about the y-axis. Up here, we were integrating with respect to x. The x-axis goes left and right, so the upper and lower bounds were the left and right x values. Well, with respect to y, the bounds are not going to be left and right anymore. They're going to be up and down. So the lower bound, C is what I'm calling it here, is the y value on the bottom, and D is the y value on the top. So we're just kind of changing our point of view here. No longer with the x-axis, we're looking at the y. And with your integrand, it's not going to be top function minus bottom anymore. It's going to be the function that forms the right part of your shaded region minus the function that forms the left part. So, I mean, all of these things are kind of confusing when you put them all together like that, which means, you know, on a test or a quiz, I'd probably want to lay this out on my cheat sheet. If I'm integrating with respect to x, set it up like this. All of these things in blue are pretty helpful. If I'm integrating with respect to y, I have to set it up like this. And again, all of those things in blue are very helpful. Okie doke, so here are the directions, and this is really directions for the entire lesson today. It should be the same set of directions from the first couple parts. It says sketch the region bounded by the graphs of the equations and find the area of the region. Sketch the region bounded by the graphs of the equations and find the area of the region. So we are going to do a little graphing if you want to grab your graphing calculator. All right. First one up here, it says f of y equals negative y squared plus 2, and then x equals negative y. you'll notice that these equations look kind of weird. First of all, the f of y notation, let me explain that for just a second. F of x equals, we all know that that is the same as y equals. So f of y is going to be the same as x equals. It's just kind of opposite notation here. Usually we've got x's on this side, but now we have y's on this side. Okay, but the reason for that is because we're going to integrate with respect to y. Now, if I'm about ready to use my graphing calculator to see what these look like, I really need to get them to have y equals out front. If you look at your calculator, the button that you press to graph functions says y equals out front. It doesn't say x equals, it says y equals. So let me solve this for y. I'm going to subtract the 2. And I will have to square root eventually, but I kind of want to get rid of that negative first. This is now negative x plus 2 equals positive y squared. So square root both sides. You will need to put a plus or minus down. And so now it says y equals plus or minus the square root of negative x plus 2. I'll get that graphed here in just a second. Moving over to this side, to solve that for y, I just have to divide by negative 1, and it turns into y equals negative x. That should be pretty easy to graph. This is not going to be as easy, so I'll probably go to my graphing calculator to figure out what that looks like. Okay, now I'm not sure if there's a plus or minus button somewhere on here that you could use, but I'll show you the way I type in the positive and the negative. Positive square root of negative x plus 2. I mean, you don't have to put a plus sign in front of it. You can just leave it the way it is, and it's positive. But I also need negative square root of negative x plus 2. So we've got the positive and the negative. They're going to look like two different functions up here on the board because one is in blue and one is in red. But remember, this is actually supposed to be one function altogether. I just had to kind of graph them in two different spots. So I'm going to make a list of some nice points that I need to put on my graph. 2, 0 is a nice point. Now, you could actually hit second graph if you want to get more nice points, but I should kind of explain how this is working. Your x values are over here. This is the y value of the first function that we graphed. This is going to be your y values of the second. I'm saying first and second, even though they are actually the same function. But here's some more points that we can use. My 2, 0 is already here, but 1, 1 is a nice point. 1, negative 1 is a nice point. Negative 2, 2 is a nice point. And negative 2, negative 2. That's another nice point that I can put on my graph. So let me go ahead and put those on here. Okay, 2, 0, 1, 1, 1, negative 1, and then negative 2, 2, negative 2, negative 2. It's almost kind of like a parabola on its side. Now, the other function said y equals negative x. that means it has a y-intercept at 0 and a slope of -1. So you can go down 1, right 1, or up 1, left 1. And I'm looking for the bounded region, and that works out to be this little area inside. Okay, so again, the whole reason we solved those equations for y was so we could type them into our calculator. That's the only reason I solved those for y. When I go back to set up my integral, when I think about the f of y and the g of y and plugging those in, I'm going to go back, and in fact, just for the time being, I'm going to subtract all of that work from earlier, and I'm just going to show these functions because those are the ones that you're going to use in your integrand. If you're going to integrate this with respect to y, it wouldn't make sense to plug in functions that had x's in them. You're going to want to plug in functions that have y. Now, before I do that, I'm going to set up my lower bound and my upper bound. Again, those are y values since we're integrating with respect to y. So, lowest y value is -1, and the highest is +2. -1 to +2. And remember the order that these have to be in. It has to be function on the right, which in this case was the curved function that is -y² + 2 minus the function on the left side of your shaded region that was -y. So again, I'm setting it up just based on y's. This is lower bound, this is upper bound, and now it's function on the right minus function on the left. We can keep going with this. That's going to turn into +y. And I should be able to just integrate each part separately. -y³ / 2y plus y² / 2. And I need to take that from -1 to +2. So I'll plug in the 2 first. That'll be -8/3 plus 4 plus 2. 2 squared is 4. 4 divided by 2 is 2. Minus what you get when you plug in the -1. Now, -1 to the 3rd is -1. But there's another negative there, so right now in the parentheses, it's +1/3 minus 2 and plus, because when I square a negative, it turns positive, +1/2. Now, I'll probably go ahead and type this in, but I'm going to type it in with that minus sign being distributed. So I've got -8/3 plus 4 plus 2 minus 1/3. This is going to turn into +2 and then minus 1/2. All together, that gives me 4.5 units squared. That would be the area of our region. Okie doke. Y values, lower bound, upper bound, and function on the right. I can even label this up here if you want. Right minus function on the left. That's always how you set it up when you integrate with respect to y. Okie doke. Now we'll just try one more example here. So this is example 2. F of x equals 4 over x, and then x equals 0, y equals 1, and y equals 3. Okay, they're kind of trying to trick us on this problem. I'm going to be integrating with respect to y on this problem, but they're actually giving me my function in terms of x. Now, I guess I do like it like that when I go to graph this on my calculator because I need the y to be out front. So let's leave it like that for now. Clear everything out from earlier while we type in 4 divided by x to our calculator. Now I'm also going to think about the other functions that were given to me. What were they? X equals 0, right there. Y equals 1, and y equals 3. So I can already kind of tell that this region right here is what's been bounded in. So when I go to recopy this on my graph, I'm not even going to worry about graphing this part on the left. Let's just graph the part on the right. That's where all the action is taking place. Now I can hit second graph to bring up a table again. And keep in mind, we're only looking for that right-hand side. So here's some nice points for us. 1, 4 might be nice. 2, 2 might be nice. 4, 1 might be nice. And that's probably all that I'll take for now. So let's put this back on our graph. 1, 4, 2, 2, and then 4, 1. This is a curve going right around that way. Now the other lines, you've got x equals 0, which is a vertical line at 0. Y equals 1, there's the horizontal line at 1. And y equals 3. So I already kind of bounded this in on the other screen, but I'll go ahead and do it again right here. Now, they give me the function in terms of x, which kind of makes me think that I'm going to integrate with respect to x, but that's not the case. This bounded region, it would be kind of hard to find the area of it if you integrate with respect to x, because your integrand would have top function minus bottom function, and you could find your x values pretty easily, the 0 here and the 4 right there. But if you just take 3 minus 1, it would just be 2, and all you would be integrating is 2 with respect to x. That's not going to give you an accurate answer because doing it that way doesn't even take this function into consideration. If you integrate 2 from 1 to 4, it's going to give you that area of the entire rectangle here. It's not going to count the other function. So integrating with respect to x is not even a very good idea with this problem. Now, because I'm choosing to integrate with respect to y, I need to get this function to have x equals out front instead of y equals. So I'm basically solving it for x. You can multiply by x first, just to kind of get it out from the denominator, then divide by y. So it's the same as x equals 4 over y. That's what I'm going to use over here in my integrand. Now, before I do anything else, the bounds here, remember we're thinking y values, lower bound is 1, upper bound is 3, and I'm integrating with respect to y, so I need function on the right minus function on the left. So function on the right, I'm using 4 over y, not 4 over x, because it would be weird to have x's if you're integrating with respect to y. Now this, again, is the function on the right minus the function on the left. Well, that's nice. The function on the left was just x equals 0. And so this is what I'm integrating with respect to y. I'll just go ahead and write it as 4 over y dy. Now, how to integrate this? I would probably pull that 4 out front. Think of that as 1 over y dy. And you can try to do the power rule here. If you rewrite that as y to the negative first, when you go to add 1 to your power and put your new power on bottom, you'd be dividing by 0, which is no good. And I told you a little while back, anytime that happens, go for the natural log function. Remember, the integral of 1 over x dx was natural log of the absolute value of x. I got to keep that 4 out front, but this is going to be 4 times the natural log of the absolute value of y. And we got to take it from 1 to 3. Now, plugging in the 3, absolute value of 3 is just 3. And then plugging in the 1 right here, absolute value of 1 is 1. And we should be able to just type that into our calculators. If you do it all at once, remember to end your parentheses after the 3. Your calculator will start the parentheses. You need to end it before you hit -4 natural log of 1. But I think that should end up being 4.39 units squared. Okie doke. Now the assignment only has 3 problems in it, 27, 29, and 31. This is C95 here. So I think 27 and 29 are kind of like the first problem that we had today. 31 should be pretty similar to example 2.